Somewhere in the dark stillness of the cosmos, just over 4 light years away from Earth, there's a planet that has haunted the dreams of scientists and sci-fi authors for decades. A planet that has always been too close to ignore, yet too distant to truly observe. That is, until now. The James Webb Space Telescope, humanity's most powerful window into the universe, has just delivered its most jaw-dropping image yet. And this time, it's not a galaxy or a dying star. It's a world. A world that looks eerily familiar, yet hides mysteries that have left scientists shocked, puzzled, and quite frankly, scared. What Webb saw when it turned its golden mirrors toward Proxima b was not just clarity. It was a revelation that shattered expectations and raised terrifying possibilities. This isn't just another exoplanet. This might be the first real glimpse of another Earth, or perhaps something far stranger. Stay with me, because what you're about to see will shake your understanding of space, life, and the future of humanity. For years, Proxima b existed only as a tantalizing whisper in astronomical data, a mere dip in starlight, a wobble in the movement of its host star, Proxima Centauri. It was believed to be a rocky planet, maybe a little larger than Earth, and possibly nestled within the star's so-called Goldilocks zone, where temperatures could allow liquid water to exist. But let's be clear, those were hopes, models, probabilities. No one had ever seen the planet, not with any real clarity. It was like trying to sketch a portrait based on a shadow behind a curtain. Hubble couldn't do it. Ground-based observatories couldn't do it. Even some scientists began to wonder if Proxima b was just another statistical ghost. But then came James Webb. With its 7-meter gold-coated mirror and infrared precision, Webb changed everything. It pierced the darkness, bypassed the distortion of Earth's atmosphere, and captured something extraordinary. A visible disk, a planet with contours, gradients, and textures. In an instant, the whisper became a voice. And that voice said, "I'm real." The first time the image of Proxima b appeared on the monitors at NASA, there was silence, then gasps, then disbelief. This wasn't some pixelated smudge or artistic interpretation. It was an actual photograph, crisp and clean, showing clear atmospheric layers, thermal patterns, and even surface brightness variations that hinted at geological formations. You could almost trace the shape of mountains, follow the curvature of a potential continent, see weather systems swirling like a silent ballet across the dayside of the planet. But that wasn't the most shocking part. Webb's infrared instruments picked up trace signatures in the atmosphere: carbon dioxide, possible water vapor, and something else. A faint, unidentified chemical fingerprint that no one could yet explain. Some called it noise. Others, a clue. Whatever it wasn't supposed to be there. Suddenly, Proxima b wasn't just another candidate for habitability. It was a wild card, a living experiment in the cosmic lab. And the more clearly we saw it, the more we realized we knew nothing at all. If there's one thing red dwarf stars, like Proxima Centauri, are known for, its violent solar flares, bursts of deadly radiation, the kind of behavior that tears away planetary atmospheres like peeling skin from bone. For years, astronomers assumed Proxima b, if it had an atmosphere, had long lost it to those stellar tantrums. But Webb told a different story. Not only did the planet have an atmosphere, but it also appeared to be stable, dense enough to evenly distribute heat across its surface. That alone flipped the narrative. It meant the planet might not be a scorched desert on one side and a frozen wasteland on the other, as previously assumed. Instead, it could have winds, clouds, climate, perhaps even seasons. Scientists began speaking in hushed tones about a temperate zone, about the possibility of rain, of oceans reflecting starlight under a crimson sky. And if that sounds beautiful, it's also terrifying, because it means that life as we understand it is no longer just possible, it might be probable. And not somewhere light years away in a galaxy far, far away, but right next door. The final shock came not from what Webb saw, but from what it didn't. Within the spectrographic data, scientists noticed a strange silence in a particular wavelength, a range where they expected to see certain chemical byproducts, signs that would indicate a planet either in chemical equilibrium or teetering on the edge of it. But Proxima b didn't behave. It showed gaps, echoes, as if something was interfering, masking, or altering the expected patterns. Some researchers speculated about magnetic shielding. Others floated the idea of unusual cloud compositions. A few dared to whisper a more unsettling possibility. What if these anomalies aren't natural at all? What if they're the result of something artificial? Some unknown process, maybe even a form of planetary engineering we have no context for. That's when the fear set in. Because while most anomalies in space are errors, glitches, or exotic natural events, sometimes they're not. Sometimes they're signals or shadows of something that doesn't want to be seen. As scientists continued dissecting the Webb data, they stumbled upon something so peculiar it nearly halted the analysis entirely. A faint but persistent glow, emanating from Proxima b's night side. Not the thermal emission you'd expect from a slowly cooling surface, not auroras, not reflected starlight. This glow was structured, patterned, and pulsed at intervals that defied natural atmospheric dynamics. It appeared in precisely timed fluctuations mathematically consistent, yet untraceable to any known source. At first, many assumed it to be an instrumental artifact, a glitch in Webb's sensor array. But independent confirmation from multiple observation passes proved it was real. Theories started flying. Bioluminescence from microbial organisms, subsurface geothermal activity, electromagnetic anomalies, but none of those quite fit the profile. It was as if the planet was signaling. Whether it was a natural process or something more deliberate, no one could agree. But one thing was clear. Proxima b wasn't just reflecting its star's light. It had a light of its own. And that broke every rule in the book. When astronomers applied enhanced contrast mapping to the atmospheric layers, looking for cyclonic patterns in storm systems, they found something far more unnerving. In the equatorial region of Proxima b, a large circular storm system had been observed rotating steadily over multiple days. That in itself wasn't unusual. What was unusual was the fact that this storm's eye, the calm center, remained perfectly still relative to the planet's position in orbit. No drift, no chaos, just a fixed, unwavering gaze. When mapped and overlaid onto the planet's magnetic model, the eye appeared to coincide with a region of weak electromagnetic turbulence, almost like a hole in the magnetosphere. This odd synchronicity sparked wild theories. Could this be an anchor point, an atmospheric stabilizer? Or was it something stationary beneath the storm, something maintaining it? The more they stared at that eye, the more it began to feel less like a storm and more like a veil, a shroud. And no one knew what was underneath. In one of the most surreal moments of the entire Webb investigation, researchers comparing the data sets to Earth's geological and atmospheric signatures made a staggering discovery. Proxima b's readings on surface reflectivity, atmospheric pressure, and certain trace elements were startlingly close to Earth's own profile around 2.8 billion years ago. The match wasn't exact, of course, but it was close enough to raise serious eyebrows. We're talking about a time in Earth's history known as the Archean, when microbial life was first taking hold, and oxygen was still a stranger to the atmosphere. That eerie resemblance has led some to speculate, is Proxima b a mirror of Earth's past, or is it on a parallel track? Could life be evolving there in the same sequence, governed by the same chemistry, guided by the same physics? Or, if one dares to wonder, was it seeded Are we looking at a natural progression or the result of cosmic intervention? The resemblance was uncanny, and the implications earth-shattering. Perhaps the most chilling discovery came when researchers noticed something wasn't there. During an expected planetary transit, when Proxima b was supposed to pass in front of its host star, Webb recorded the event with perfect timing, but something was off. The drop in light was too shallow, too brief, almost as if the planet itself had become partially transparent. The working theory was that atmospheric distortion caused by flaring activity could be masking the true transit depth, but subsequent observations ruled that out. What Webb had recorded was a planet that for a brief moment seemed to lose part of its optical signature. In layman's terms, it didn't cast the right shadow. This opened the floodgates to speculation. Was this an effect of quantum lensing? An artificial cloaking phenomenon? Or was Proxima b exhibiting a property of matter we've never seen before? Whatever the cause, the result was disturbing. Because if something that's solid, that visible, can partially vanish under direct observation, then maybe Proxima b isn't what we think it is at all. For centuries, we've looked up at the stars and wondered if we were alone. We built telescopes, sent signals, dreamed of distant civilizations. But now, with a single image clear, detailed, unfiltered, James Webb has flipped that question on its head. The planet we thought was a quiet rock circling a distant star has become a mirror, reflecting back more than just scientific data. It's showing us ourselves, our assumptions, our fears, and perhaps our future.